Arithmetic operations. These are simple mathematical operations like addition, subtraction, multiplication, and division. These operations can be performed in any number system. As we are already familiar with these operations in decimal, let's learn how to perform them in binary by drawing out parallels from how we perform them in decimal. Let's start with the basic one, which is addition. Addition of two numbers involves addition of their corresponding digits, demanding the need to remember addition tables. Let's recollect the procedure. We start by adding the rightmost digit of the first number to the corresponding digit of the second number and note the result. We then move one position to the left and add the next corresponding digits. If the result is a two-digit number, we note down the rightmost digit and carry forward the rest to the next position. Next, we move one more position to the left and add the corresponding digits along with the carry forwarded from previous operation. In this fashion, we add all the digits one by one from right to left, forming the result. Adding binary numbers is exactly similar to what we just did in decimal, only the addition tables change. 0 added to 0 is obviously 0. 0 added to 1 or 1 added to 0 yields a 1. And 1 plus 1 gives 2, which is 1 0 in binary. Using this addition table, now let's add the same numbers in binary. Binary equivalent of 2165 is this 12-digit number, and binary equivalent of 1252 is this 11-digit number. Let's add these numbers from right to left just as we did with decimal. First, we add the rightmost digits. Looking up the addition table, we know that 1 plus 0 is 1. We now add the next digits, which is 0 plus 0. Refer the table and note the result. Next, we add 1 plus 1, which gives 1 0. Since it's a two-digit number, we note down the 0 and carry forward the 1. Now we add the next digits along with the carry. Continuing in this fashion, from right to left, we add the rest of the binary digits. If you convert this result from binary to decimal, you can verify that we ended up with the same result that we got in decimal previously. You can always cross-check your binary arithmetic results this way. Here are some more examples of addition in binary. You can pause the video and have a look. Let's now move on to subtraction and recollect how would we subtract one decimal number from another. Just like addition, we start from the right and subtract the digit of the first number with the corresponding digit of the second number and write down the result. We then move to the left and subtract the next digits. If the digit of first number is lesser than the digit of the second number, then we borrow a 1 from the next immediate digit. The digit that borrowed the 1 becomes 1 prefixed to its value, and the digit that lended the 1 becomes 1 lesser than its value. Now we can subtract these digits and get the result. We continue in this fashion till the leftmost digit to get the result of subtraction. Let's wrap it up with one more example. As always, we start from the right. The 2 is lesser than the 5, so we need to borrow a 1 from the next digit. But the next immediate digit is a 0. Poor guy. Being a 0, he can't offer anything to his friend. So he thinks of borrowing a 1 from the very next guy. That digit again being a 0 is empty-handed to lend anything. So he borrows a 1 from the very next guy. This loan lessens the 3 by 1, making it a 2. The 0 prefixes itself with the borrowed 1 and becomes a 10. He then lends a 1 to the next 0, which lessens him by 1, making him a 9. This makes the next 0 a 10. It then becomes a 9 by lending a 1 to the 2 who actually started this entire transaction. The 2 finally becomes a 12. Now it's quite easy to carry out rest of the subtraction. The 12 minus 5 is a 7. 9 minus 4 is a 5. 9 minus 2 yields a 7. And 2 minus 1 is a 1. So the result is 1757. Let's now have a look at subtraction in binary with the following example. As always, we start from the right. 1 minus 1 would be a 0. 0 minus 1 cannot be done since 0 is less than 1. So we borrow from the next digit. So this 1 gets reduced by 1 since it supplied the borrow and becomes a 0. And the 0 that got the borrow prefixes itself with 1, becoming 1 0. Let me remind you, this is binary, and so this here is 1 0 but not a 10. And we all know 1 0 in binary equals 2. Repeat it to yourself a few times until you get used to this binary system. And once you get the hang of it, trust me, it really becomes a cakewalk. Now let's resume the subtraction. 1 0 minus 1 would be 2 minus 1, which is a 1. 0 minus 0 would be 0. Again, 0 less 0 is a 0. Once again, we have this situation of 0 less than 1. So we need a borrow. But as the next digits are chain of zeros, just like our previous example from decimal, we get the borrow from nearest non-zero digit. So this 1 becomes a 0 by lending a 1 to the previous digit, making it 1 0. Now this 1 0 lends a 1 to the next digit. So this 1 0 is reduced by 1 and becomes a 1. And the 0 that borrowed the 1 prefixes itself with a 1, becoming 1 0. Again this 1 0 lends a 1 and becomes 1. Finally, the actual digit that started the transaction gets the borrow and becomes 1 0. Now it's quite easy to carry out rest of the subtraction. So 1 0 minus 1 would be a 1. 1 minus 1, a 0. 1 less 1 again is 0. Now 0 borrows a 1. So 1 0 minus 1 would be a 1. And so we get the final result. We can convert the given numbers and the result from binary to decimal to cross-verify. This way of cross-checking our binary operations always comes in handy during initial days of learning binary. Here are some more examples of subtraction in binary. You can pause the video and have a look. So now we know how to perform two of the arithmetic operations in binary, that is addition and subtraction. The remaining arithmetic operations, that is multiplication and division, will be covered in the next video.
Hey there, hope you like the video. This video is part of series called Computer in a Nutshell. If you are new to computer science, then this is the only series you'll ever need to get started. Because this series will take you on a crazy ride, starting from what is a computer, to what's inside a computer, to how each part of computer works, leading all the way up to Introduction to Programming.
To get started on this series, you can head over to my channel and dial into Computer in a Nutshell playlist. Here, you can find all the videos from this series in chronological order. You can also find links to the videos from this series in the description of every video.
If you find this video informative, please share it forward. Subscribe to our channel for more such videos. Click here to watch the next video from this series. You can also check out our previous video from here.